another way to change velocity. So far we've talked about speeding up or slowing down as potential ways to change your velocity in a car. But there's another way. Remember that velocity is a vector. So by using your steering wheel, you are changing directions of the car. By changing directions, you're changing your velocity. So this is why it's so important to remember that vector is a magnitude and direction. So if you change the magnitude or the speed, how fast you're moving, then you're accelerating. And if you change the direction that you're moving, even if your speed stays constant, if the direction changes, then you are accelerating. A last way to change directions is to slow down past 0 and then keep moving in reverse. Alright, some motion diagrams or strobe diagrams. Here we have the first one where there's a constant speed, dot, 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 dot. Equal spacing between each dot. Again, this is a strobe photo, so Halloween time with the strobe lights and the flashing every equal time interval. So it's here, we see the light, and then it's dark for a little bit, and then light flashes, dark for a little bit, light flashes, and the dots here. Dark for a little bit, light flashes, and the dots here. So now, if we start at the second one, we are accelerating. There's a small distance between these. Bigger distance, bigger distance, bigger distance, bigger distance. So now our distance between them is increasing, but the same amount of time is coming. So we haven't changed the speed of the strobe light, but now we're seeing how fast or how the velocity is changing or the speed is changing. This is with a little bit of acceleration. Now looking at lots of acceleration. This is just an exaggerated version of this second. So here, kind of a big jump, and then we're doubling, and then it's huge, and then it's huge, and then so on. Here is the equation. Acceleration equals delta V over delta T. What does delta equal? Change. Change is final minus initial. All right, on to our example problem. At the start of a race, a toy car increases speed from 0 meters per second to 5 meters per second as the clock runs from 0 to 2 seconds. Find the acceleration of the car. All right, so as we move forward with this class, it's going to get more and more difficult to figure out what is the question asking you. So I am proposing a problem-solving method where we guess. G-U-E-S-S. We write down our given information, we write down the unknown information, we write an equation that relates these two, or two equations, whatever the case is. We solve, and then we ask ourselves, does it make sense? Alright, the first part, at the start of the race car, a toy car increases from 0 to 5 meters per second. So we have this 5 meters per second here. That is our ending speed, or the final velocity. There it is. The starting velocity or starting speed is 0 meters per second as the clock runs from 0 to 2 seconds. We also know the final time is 2 seconds and the starting time is 0 seconds. Well, what is unknown? The question says find the acceleration of the car. Guess what the unknown variable is? A. We don't know what A is. We have an equation, A equals delta V over delta T, and then we're going to solve. Delta means final minus initial, final minus the initial, 5 minus 0, divided by the final minus the initial, 2 minus 0. We get an acceleration that is positive and is 2.5 meters per second squared. Does that make sense? Yes, it's small and it's positive. Tangent lines give an instantaneous velocity or an acceleration. I showed you how the tangent lines work earlier on when we were covering the investigation, so I won't go through that again, but look at our distance time graph for constant acceleration. We have this curve that goes up, which is just like we had in the investigate. The slope of this line is still rise over run, so the slope is the change in distance over the change in time, and that gives us the velocity. The slope of a distance time graph is velocity. So from this same graph, if we took the slope at each of these points, because our slope is constantly changing, then we plot it, then we have a constant velocity. constant increase in velocity. Careful. So our velocity is getting bigger as time goes on. Now, the slope of velocity versus time, slope is rise over run. The rise is delta v, the change in our y-axis, over delta t gives us our acceleration. So the slope for a velocity versus time graph is acceleration. Both of those are important to have as a fact in your brain. The slope of a distance versus time graph is velocity, and the slope of a velocity versus time graph is acceleration. Here are a couple of graphs to show you what you would expect for something in different situations. We'll start with a car at rest. Notice this is a distance time graph. The position does not change, so it's flat up here. For the velocity versus time graph, the velocity is 0 because our position doesn't change. There is no slope to this line right here. For the acceleration versus time graph, well, if we have 0 velocity for the entire time, guess what our acceleration is going to be? 0 for the whole time. Here is an automobile with constant velocity. We have the constantly increasing position. Distance increases at a constant rate. That gives us a constant velocity. So our velocity, it's going up, so it must be a constant positive velocity. Velocity versus time graph, positive, and it's not changing, so it's constant. The change in distance versus time is constant, and therefore the velocity is constant rate. Now if we take the slope of this graph, what do we get? Rise over run. Rise is 0. So that means 0 divided by anything is going to give us 0. There is a constant velocity, so there's no change in velocity, so there is 0 acceleration. An automobile with a constant acceleration, just like we had with a car going down the ramp. Our velocity started out slow and then increased a lot more rapidly. So our velocity was constantly changing, is how we would read that. If our velocity is constantly changing, the speed is increasing, as can be seen by the increasing slope of the distance versus time graph. So now we have a line that we can take the slope of. We can do rise over run for this line. The velocity is changing at a constant rate, so that means the automobile is moving with a constant acceleration. And because we're moving to higher velocities, more positive velocities, that means we have a positive acceleration. And in this case, it's not changing. If we do have a changing acceleration, that means we're going to have to use calculus. And chances are, if you're watching this video, that's not something you have grasped just yet. So we don't have to worry about it. Here are some checking up questions. By the end of this video, make sure you fully understand what all of these are and how to do it. And then finally, don't forget to do your what do you think now. That's it for section 4. Don't forget to do your physics to go questions. Bye.